2, 3, funky.
Welcome back to the channel, and I hope you're having a good day. In today's video, I'm going to go over some more review on the electromagnetic spectrum. And yes, before we start though, I do want to say that this should be the last part of like this whole wave review. So yeah, this is the fourth and probably final. However, today is the 30th of March and today's to March 31st. Test is on the 1st. I might go over the test reviews, like the study guide and like the Quizlet. I might, that's a big but, I might, did I even say the word but? Anyways, I might do like a little note compilation of like the Quizlet combined with the study guide and like help you guys a little bit more. Probably not gonna happen though. But anyways, this is this video, and if by the end of this video you need anything, just just talk to me. Anyways, number one, we have visible light, and the definition basically is the ability for it to be detected by human sight. So like if humans are able to see it, then it's visible light, so we have to be able to see it. Number two, seeing all the colors of visible light at once will cause you to perceive a white light. So the way I got it wrong at first, but the way I kind of think about it is like, how there's always like that pyramid and like it's white and then just the colors bend through it and it's like rainbows. That's kind of how I think about it. So like the rainbows would form into that white light pyramid. So that's the answer. This is wrong. It's not rainbow, it's white light. It will cause you to perceive white light. Number three, correctly arrange these colors of light in order from the longest to the shortest wavelength. Just went over this in my last video, but here it is again. So your longest wavelength is red and your shortest is going to be violet. So it's in order. So red, then orange, then yellow, then green, and then cyan comes before blue. So cyan, then blue, and then violet. If you had indigo would be 7 and violet would be 8. There's that. Number four, which color is traditionally included in the visible light spectrum but does not really exist as a distinct color of light? The answer is indigo. I put cyan, but the answer is indigo. I don't necessarily know why that is or how that works, but your answer is indigo. So yes, that's that. Common uses of ultraviolet light in professional life include detection of otherwise invisible clues at the crime scenes. So it kind of works like yeah, do you guys know like the lights that you put and then it makes like the bacteria show up and you kind of see like the little particles? I feel stupid for not knowing the name of it, but like that's kind of the vibes that I get. Wait, it is ultraviolet light, UV light, I think, maybe. Let's move on. And the sterilization of lab materials, so it sterilizes stuff. That's ultraviolet light. Let's move on. Which of these is a danger of overexposure to ultraviolet light? The answer would be melanoma, which is, I think, skin cancer. Something that has to do with your skin. That. 7. Whatever. X-rays are dangerous because of... Why do I know I have number 7? Wait, was that number 7? No. I'll put it on the screen, whatever the answer is. I'm sorry. Number 8, though. Common uses of X-rays in professional life include medical diagnosis. And you could also detect dangerous items in cell containers because you can see right through it. For detecting heat sources, that would be, I think, infrared. It shows you like the heated parts, the cool parts, and stuff like that. And for heating food, that should be microwave. What is the minimum size of gamma wavelengths? It is unknown. We only know like a range of what it could possibly be, but we don't actually know. So the minimum size is unknown. We do know the max, which I currently do not know, so I'm not even going to talk about it. While gamma rays in large amounts are usually produced by very violent explosions in space, which natural events on Earth can produce smaller amounts? That will be lightning. Yep, cool. lightning, very dangerous. You do not want to get struck by lightning, which showed you how dangerous gamma rays can be. So let's move on. Last little section. So they want us to range from the highest frequency, which is also the shortest wavelength, to the lowest frequency / longest wavelength. So your highest frequency is going to be your most dangerous because it has the highest amount of energy. So you go from gamma rays to X-ray, ultraviolet to visible light, then to the safe side, which is infrared, microwave, and radio. Whenever this in my last video, if you want to check that out, it goes in that order every single time, so don't worry about that. I'll put a picture up on this and you can go over there. And that is the end of this. I hope you learned something new and found the video helpful. I would love to see you in the next one. Bye.